Today's topic is about integrations of irrational functions. Okay, as you know, irrational functions are of this type: square root of something, square root of any fx, or cube root of any fx. Okay, now there are four cases for irrational functions. Okay, now first case is 1 upon square root of x square plus bx plus c, where a should not be equals to 0. Okay, if a is 0, then this case will not be valid. Okay, similarly over here, this is 1 upon this, and square root here, this is square root of x square plus bx plus c. Okay, now in this scenario, what we have to do is we have to make perfect square. Okay, in this form, either in this form here a square minus x square, or in this form, either this way, okay, or this way, or this way. Most of the irrational functions of integration will come under this formula. Okay, these are 1 2 3 4 formulas. So we have to try to bring into whatever you have in this form. Okay, now in the case 3 also, now you have to check differentiation of this is how much is coming. For example, if you have, instead of this, if you have, for example, twice x square plus 4x plus 5. Okay, now what is differentiation of this? Differentiation of this is what? You have 4x plus 4. Okay, you have to adjust with this with respect to differentiation of this. Okay, in this type. Similarly here also. Okay, now in this case you have to make the coefficient of x square as a 1. Okay, first case and second case, you have to make coefficient of x square as a 1. Meaning, for example, if you have this, then if you have to make coefficient of x square 1, then you have to divide this, dividing 2. Okay, here if I divided 1 by 2, then I'll be getting x square plus 4. Means you have to divide. Okay, if you can take common also. If you take common, here you have x square plus 2x plus 5 by 2. Okay, you have to, if it is associated with some constant, or you can say the coefficient of x square is if you have something. Okay, then you have to make it linear, or you can say make it 1, so that you can apply one of these formulas. Okay, let's take some example. With the help of example, we will come to know how to use these formulas in association with this case. Okay, now first case, we will be solving few sums for first case. Now let's take question number 1. Okay, now it is given that 1 upon square root of 8 plus 3x minus x square. Okay, now here you have minus x square. Okay, so let's consider this term. Okay, and then we'll manipulate either this way or this way. Okay, let's consider 8 plus 3x minus x square. Okay, now minus is in front of x square, minus doesn't look nice. Okay, so let's take minus common. I can take minus common. If I take minus common from whole, then I will have x square minus plus 3x minus plus 8. Check it here, x square minus plus 3x, here minus x, so minus 8. Now we have to make what? Perfect square. Okay, now mapping perfect square is what? Here x square, it is either on the form we have x square plus, you can say we have a minus b whole square is what? A square minus twice ab plus b square. Okay, now let's see, x square is we have minus, for formula I need 2. Okay, and then since it is already assigned x square, we have 2, we have, since a is there, a should come over here. Since x is there, x should come over here. Okay, but I need to adjust b. I need to get adjust b, so that I should get 3x over here. Okay, so now if I insert, I should get 3. Okay, if I insert 3 upon 2. Okay, why? Because I should get 3x. Okay, for formula x square, I have a square minus 2. Since a is there, I have to put a. Okay, since x is there, I have to put a. Okay, Now I need to get 3x. Okay, in order to get 3x, 2 gets cancel. 2x is there, 3 by 2. Since it is b plus, okay, I need to have b square. Since I already have 3 by 2, I need to have 3 by 2 the whole square. This is my requirement. Okay, this is my requirement. This is extra minus this is extra, so I need to get cancel. What I'm doing is I am applying a minus b the whole square. Here a square we have x square twice a. Since I already assigned x, I should have x over here. B. Why I need to get 3x? I already have twice x up to here, or I already have. Okay, so I need to assign some number such that I should get 3x over here. Okay, so if I insert 3 by 2, then 2 gets cancelled. It will give 3x. Okay, now this is already my b. So my b, then in order to make formula, it should be b square. Okay, now this extra I am cancelling with this. Minus 8 is already over here. Okay, now this section, okay, now this section is what? A minus b whole square type is minus here x minus 3 by 2 the whole square minus 8 minus 3 3 is 9 upon 2 2 is 4. Okay, now let's take LCM. Minus x minus 3 by 2 the whole square minus. Okay, here if I take LCM, or you can do one thing, if I take minus common, okay, if I take minus common, then this become a plus. Okay, so let's take minus here 4, 32 plus 9. This is same as minus x minus 3 by 2 the whole square minus here 9, 10, 11, so 41 upon 4. So 41 upon 4 is same as, if I want to write in terms of square, so 4 is same as 2 square, 41 is same, so we don't have any perfect square, so I can write root of 41 the whole square. Okay, so this is same as whole. Okay, I can write like this. Okay, so if I send minus inside, this will be plus, so plus I can write first root of 41 by 2 the whole square minus x minus 3 by 2 the whole square. Okay, therefore instead of this I can write like this. Okay, therefore this equals to square root of this is what? This is same as this, so square root of 41 upon 2 the whole square minus x minus 3 by 2 the whole square. Look at here, it is only from a square minus x square. Here a square minus x square. Okay, it is same as sine inverse x by x. This is same as sine inverse. What is our x? Okay, this x is, if you take LCM, here you have twice x minus 3 upon 2 x upon, what is a? Root of 41 upon 2 plus some constant. Okay, this is the required answer for 1. Let's take next sum over here. Now it is integral of 1 upon square root of 5x square minus 2x. Okay, now what we can do is, we have to make, as I told you, we have to make the coefficient x square singular. Okay, so let's see. Okay, now consider 5x square minus 2x. Okay, so from here I can take 5 common. Okay, if I take 5 common, why? Because it should be, the coefficient of x square should be linear, so that I can apply, so that I can make a perfect square. Okay, it's same as 5 x square. If I take 5, then it will be what? 2 by 5x. Okay, because 5 gets cancelled. Now in order to get the perfect square, let's see, x square minus, okay, twice a, okay, here twice a b, I need to assign b, Can I assign 1 by 5? Because it is same as twice AB plus 1 by 5 the whole square. This extra, but I need to cancel minus 1 by 5 the whole square. What I am doing is, here x square, 2 into x into 1 by 5 is same as 2 by 5x. Since I need to get b square, so b already I am having, b square minus this extra, so I am cancelling with this, okay. Now this is become what? 5, this is become x minus 1 by 5 the whole square minus 1 by 5 the whole square, okay. It is already from a square minus x square minus a square. What? It is x square minus a square, this form, okay. So but therefore this is equals to 5 I can send outside, okay. So it will be 1 by 5 integral. Instead of this I can write square root of x minus 1 by 5 the whole square minus 1 by 5 square dx. 1 by 5, applying this formula here, log of x plus this, okay. Here we have log of x is what? This is our x, okay. This is our x, this is our a, okay. Here if I take LCM, you can keep like this. X means if I take LCM, you can keep x minus 1 by 5 x plus this, okay, or this is what? X square minus a square, okay. Here you can keep all this square root of, you can keep same, or you can keep this, or you can keep this. Here you can keep 5x square minus 2x square root plus some constant c here, okay. This is the easiest way. Otherwise what we can do is, you can bring 5 most of the time, okay. You can, what you can do is, you can another method is, you can do one thing. This is same as root 5x the whole square. You can bring this as a, okay. Similarly you can associate minus twice a means root 5 x, I need to get 2, okay. So it will be 1 upon root 5 plus 1 by root 5 the whole square minus 1 by root 5 the whole square. Similarly this also can, here this will be what? Root 5 x minus 1 by root 5 the whole square minus 1 by root 5 the whole square. This is all from x square minus x square. Same answer will come. But be careful when you differentiate over here. dy dx of x is 1. That's why you have not written over here. Now here root 5 will come over if you use this way, okay. Now next sum, question number 3. Look at here, okay. In this integral we have sine of 2x. You have angles are different over here, okay. You have 2x over here, sine of twice x, but all here you have sine x, okay, here. So cos 4x and sine square x. Now you have one angle here, one angle here, you have double angle here, okay. So you have to bring it down to the single angle, okay, and then let's see how it works, okay. You have to substitute. Let's see, this equals to sine 2x is what? 2 sine x into cos x upon, now cos 4x is what? I can say cos square x the whole square minus sine square x plus 2, okay. Now instead of cos square I can say cos square is what? 1 minus sine square x, okay. This same as 2 sine x into cos x dx upon cos square is same as 1 minus sine square x the whole square minus sine square x plus 2. Why I am doing? Because if I substitute t equals to sine x, I will be getting cos x dx as a dt, okay. Now if I substitute, say if I put t equals to sine x, now my dt will be what? cos x dx. Okay, now whole will be in terms of algebraic. Then we can think of what will come. Okay, this is same as if I putting 2 is constant outside, sin x is what? T. Okay, here t into cos x dx is dt upon 1 minus, here 1 minus sin square. Here I am putting what? Sin square. Okay, here is same as t square the whole square minus t square plus 2. Now again you expand integral t dt upon here 1, if I a minus b the whole square is a square minus twice ab plus b square means t raised to 4 minus t square plus 2. Okay, this is same as 2 t dt upon here t raised to 4. Here we have minus t square minus 2t, here will be minus 3 t square, here 1 plus 2 is plus 3. Okay, now here we have all square roots. Okay, here we have all square roots we have. Okay, here we have square root, here we have square root, here we have square root, here we have square root. Okay, now again we have to substitute once again. Okay, now if I substitute t square equals to m, look at here. Now if I substitute once again t square equals to m, okay, then twice t dt will be dm. Okay, twice t dt, so I can send 2 inside. Okay, twice t dt will be dm. So this is become dm upon, now t square. Okay, this will be what? M square, square root of m square minus 3m plus 3. Okay, now let's consider this. Now consider m square here dm. Let's make perfect square here. Okay, here we have m square minus twice I need m I need. Okay, I need to get 3. Okay, so in order to get 3 I need to have 2, 3 by 2, because 2 gets cancelled, 3m plus 3 by 2 the whole square I need in order to make perfect square. This is extra, plus 3 minus 3 by 2 the whole square. Now this whole become dm. This is what? Square root of m minus 3 by 2 the whole square. Okay, up to here. Now this is 3 here plus 3 is a 9 by 4. Here I can write, here this is 9 upon 4. If I take LCM, 3 4 is a 12, 12 minus 9 upon 4. Okay, now 4 is 12 minus 9 is what? 3, 4. Now here, okay, here I can cite like this. This is same as 12 minus 9 is 3. Okay, so 9, 10, 11, 12. Here I can say like 3. I can write 3. Now if I want to express this the whole square, what I can do is 4 is same as 2 the whole square and 3 is same as root 3 the whole square. Okay, it is out from x square plus a square. Here what you have? X square plus a square. That is log of this. Okay, that is log of x plus, what is x? Here m plus 3 by m minus 3 by 2 plus here whole. Okay, m minus 3 by 2 the whole square root plus 3 by 2. Okay, now what is m? You have to bring it into t. Okay, and what t equals to m equals to t square. Okay, here instead of m you can write here t square, here t square. Okay, what is t square? Okay, what t is what? Sine of x. Okay, so this t will be, it will be what? Sine square. Sine square. Here this will be sine square. Okay, this is a required answer for some constant. Okay, this is a required answer for question number 3. Now let's consider case 2. Now here case 2, it is integral of the form square root of ax square plus bx plus c, where a is not equals to 0. Okay, in this integral what we do is we have to make the coefficient of x square 1, and then we have to bring into the reducing into the perfect square of the form here a minus b the whole square or a plus b the whole square form, either a minus b whole square or a plus b the whole square form. Okay, so first of all we have to make, our aim is to make the coefficient of x square unity. Here we have to make coefficient of x square unity and make perfect square. Okay, either a minus b or a plus b form. Okay, and the given integral, then the given integral reduces to x square plus minus a square, or it may be x square minus a square. Okay, now we have 3 formulas over here. Integral of x square minus a square is x by a. All this formula, we have 3 formulas. Okay, so any of the form, okay, in this form case 2 will be landing either 1, 2, 3. Okay, now let's solve the first sum. Now integral of 1 plus x minus 2x square. Okay, now here let's consider this first. Okay, let's consider 1 plus x minus 2x square. Okay, now we don't know minus is somehow not convenient, so I can take minus 2 common over here. Okay, so in order to make x square unity, coefficient unity, let's make minus 2 common. If I take minus 2 common, then x square, then what will come over here? Okay, here x square, x upon, otherwise let's do one thing, let's write this. Okay, I will take only 2. Okay, here minus x square, here x by what, plus x by 2 plus half. Okay, I'm taking only 2 common, not minus. Okay, because since square root is there, so if I want to send outside square root, it might have be somehow more complicated. Okay, therefore this sum is 2. Now again let's take minus common, it will be better. Here x square minus, if I take minus, then it will be x by 2 minus 1 by 2. Okay, here minus 2. Now let's form what? Perfect square. Okay, perfect square of the form a minus b or a minus b, a plus b. Here this is x square minus twice x into what we need? We need x by 2, right? So I can get x by 2 if I put 1 by 4, if I substitute, if I assign 1 by 4. Okay, because 2, 4, I'll have 2 over here. Okay, x square I have, twice I need for formula, x already I have, so I'm putting x over here, same x. So in order to get x by 2, okay, so I need to put 1 by 4, because 2 and 2 2's are 4. Okay, so this whole term become x by 2. Okay, now plus this is b, so I need to have 1 by b the whole square. This is extra. Okay, so I need to cut over here 1 by 2 minus 1 by 4 the whole square. Okay, this is same as minus 2. Now from here to here is we have x minus 1 by 4 the whole square, a minus b the whole square. Now we have 1 by 2 minus 1 by 4 for the 16. Okay. Now if I take x minus 1 by 4 the whole square, if I take minus common, okay, if I take minus common, then it will be what? It will be plus if I take minus common. So minus, let's take LCM, 16 to 8. 8 plus 1 is same as 8 plus 1 is what? 9. 9 upon 16. Okay, here we are getting 9 upon 16. 9 is what? 3 is a 9. Okay, so I can say 3 is 9, 4 4 is a 16. 3 by 4 the whole square. Okay. Now this minus 2 I can send inside. This minus I can send. If I send inside, then what will be 2 outside? Just I am sending minus. Okay. Minus minus plus. I will be getting 3 by 4 whole square. And this will get minus. Here x minus 1 by 4 whole square. Okay. Now whole this term is this. Okay. Now this equals to integral this square root. Okay. So whole square is there. So I will have this square root of 2 3 by 4 whole square, second bracket, minus x minus 1 by 4 the whole square. Okay, this into dx. Now square 2 I can send outside. That's become a square root of 2. Now integration of is x square minus a square. What is there? X square minus a square is of this form. Okay. Now let's apply x square minus a square. What is x? X upon 2 means if I take LCM, or you can keep like this, x minus 1 by 4 upon 2 square root of x square plus a square. You can keep like this, 1 plus x minus 2 x square minus a square upon 2. What is a? We have this. A square is, we have 3 3 is 9, 4 4 is 16. A square upon 2. Here 2 log of x is what we have, x minus 1 by 4 x plus this square root of 1 plus x minus 2x square. Okay, you can keep like this plus some constant. Okay, this is the required answer for question number 1. Okay, now in the case 1 is same. Okay, means what you have to do is you have to make, if you have to make the coefficient of x square as a 1. After that you have to make what? Perfect square. Okay, keep in mind you have to perfect square either of the form a minus b or a plus b. You bring into that, and after that you will get either x square minus a square or a square minus x square. If it is a square minus x square, use this formula. Okay, and if it is x square minus a square, use this formula. If it is plus, then this formula. Okay, so one of the three will be in that pattern by using this standard perfect square, how to make perfect square rule. Okay, this is how it solves for case 2. Okay.